to the prologue for Earth Science. And last time we met, we were talking about observation and inference. And now, moving a little bit forward, we're talking about what happens when we use instruments or we make measurements and we have massive numbers, huge numbers, like such as numbers as the speed of light, which is 300 million meters per second. So we're talking about really massive numbers here, or the exact opposite, really small numbers. Well, in those situations, scientists use what we call scientific notation. Scientific notation is just a very easy way to express very large or very small numbers. Okay, for example, there are 170, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 170, 18 zeros after the huge numbers. Oxygen atoms in a drop of water. Well, if we had to say that, I don't even know what that is. It's like 170 million. We can do this in a lot easier way. In scientific notation, what we could do is we can actually take this number and make it a lot smaller and a little bit easier to read. For instance, what it would look like is 1.7 times, and then we count those zeros again going. So we have 3, 6, 9, 12, 15, 18, 19, and we move over 1. So 10 to 19th. That's what it would look like in scientific notation. So we're going to go over a couple of things to kind of get that and take a look at how we do that. Okay, some of the rules for scientific notation as is, we're going to move the decimal point until there is only one number before it. And we're going to go over exactly what that looks like again. Very large numbers will have a positive exponent, and very small numbers will have a negative exponent. The beauty of this is that you could tell right away just by looking at the exponent if you're looking at a really big or a really small number. Okay, coming up, here we go. We have a couple examples. We have 2.73, let's change color here, 2.73 times 10 to the 5th. The 5 up here, or the exponent, is positive, so we know that we're going to have a large number. So we see 1, 2, 3, 4, 5 spaces. Okay, and so we have 2.73 times 10 to the 5th would be 273,000. To reverse that, we can make this a negative exponent right here, negative 5. And what we do is we're going to move that decimal point 1, 2, 3, 4, 5 places to the left. So you can see how a negative or a positive exponent really changes how we're going to do it. 1, 2, 3, 4, 5. Decimal points right there. So you can see in this very small, very easy example how a positive or negative exponent is going to move that decimal place either to the right or to the left. Okay, here are some examples of scientific notation again. Okay, we want to convert 345 million into scientific notation. Okay, well, the first rule we said is we have to get that decimal point between the first. Basically, so there's only one number before it, so it would be 3.45. And then we always have times 10. Now we have to count the number of spaces we move. So here's 3.45, so we go 1, 2, 3, 4, 5, 6, 7, 8. So, T8. That's it, 3.45 times 10 to the 8th. It's really not too bad. I'll change that. We're going to convert 0.000000416 into scientific notation. Not too bad to do. Okay, so we want the decimal point here. So it'd be 4.16. Here we go, 4.16, and we have to count the number of spaces. Notice we're going to the left, so we have a small number, so it's going to be a negative exponent. 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7. There you go. That's it. That's how we do scientific notation. Here's a couple more examples coming up. Okay, here we go. We're going to convert these numbers. So you could take a minute, look at the numbers, and we're going to go through converting them. Okay, so taking a look at the first one up here is 2.0 times 10 to the 7. So we know that it's 2. And because we see the 7 here, and it's a positive exponent, we're going to put 7 zeros after, or move the decimal places 7 places to the right. So here we go. 1, 2, 3, 4, 5, 6, 7. And we can put a little commas in. Here we go, there and there. And 2.0 times 10 to the 7th is nothing more than 20 million. Here we have something a little bit different. Notice we have a small number. So we're going to make it 4, 5, 9. There we go, right there. Normally the decimal place is right here. Okay, there's our decimal place. There's a decimal place. And we have to figure out how many places we're going to have to move that to get to that decimal place. So we count 1, 2, 3, 4, 5, 6. Okay, so times 10 to the 6th. But since we had to move this decimal place over, and we have a really small number, -6. Okay, this number right here. Now I'm going to attempt to say it. Here we go. We get our decimal place right here. So we do 3.0 times 10, and we got to figure out how many spaces we're going to move this decimal place over. So we normally be here 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Positive exponent, really big number. Last one, 6.93 times 10 to the -5th. So we know we have 693. Okay. Move this decimal place over to the left. So normally it would be, so we can do it right here. So -5. So it's 5 places. 1, 2, 3, 4, 5. And we fill in with some zeros. So let's get rid of that. Makes it a little bit easier. So it's 0.0000693. Double check that. 1. So let's change color here and make it look a little different. So we go 1, 2, 3, 4, 5. There we go. So that decimal point over there. 6.93 times 10 to the -5th. Those numbers are equal. We're good to go. Scientific notation, as easy as it gets. A little practice and it gets a little bit more easier as we go on. That's really about it for scientific notation. Next up, we'll talk about some more information for the prologue. Hope you enjoyed that little talk on scientific notation. Thanks a lot, and goodbye.